Good afternoon, everyone. My name is Cozad, and it's been an absolute pleasure to be working with Unidata over the past 10 weeks. And now I have the opportunity to share with all of you what I've been working on over the summer. And so I've been focusing on Metpai alongside Brian and Drew. And the kind of focus for this summer has been on progressing towards the release of Metpai 1.1. And that's been a really exciting project to work on. And I've learned a lot about Metpai, but also ecosystem that Metpai fits into, and how we're supporting a great community of researchers and students and academics that are taking what we do here and applying it to their research and making advances in these areas. And so kind of starting on the left side of this poster is a general background on what Metpai is, who would use it and why. And so one of the things I learned this summer is that Genpack is actually one of the kind of the driving forces behind why we develop Metpai and how it goes forward in the future, along with providing support for just Python users that are doing research with meteorology and atmospheric science. And so those two things together are what kind of drives forward the decisions that are made with Metpai. And my focus this summer with a number of different features that are included in version 1.1 was our declarative interface. And so the declarative interface is the part of Metpai that allows users to make different plots with their data, specifically for maps. And so if you have a net CDF file, if you have X-ray data, any kind of gridded data, then that is primarily the use case for our declarative interface. And the declarative interface was developed and designed to look just like the plotting interface in Genpack. And so what I did this summer was implement some of those features that Genpack had included, but had not made it into Metpai yet, but also to a certain extent building onto the declarative interface, things that Genpack didn't have, but that are usable and of interest for our users today. And so in addition to that, I learned a lot about how we do software development in general and how we figure out what is interesting to our community. And so that kind of gets into the methods section there on the left side, which a lot of these things start as feature requests. People are looking for Metpai to have certain functionality. And if it's not there, a lot of times they'll go to our GitHub page and submit an issue where they can tell us what they're interested in seeing. And then we can include that. And quite frankly, anyone can write the code and submit it for approval to be included in Metpai. And so that's where many of the features that I worked on this summer started. These were all first started out as issues in GitHub, and we took those and figured out how do we write the code to put this into Metpai. And so in working on that code, I figured out it's not just as easy as making something that works and stopping there. There's a lot of outside considerations to make in terms of getting code that works well for Metpai, and that starts with documentation. So every class, every method ends up having its own doc strings. And then we include comments elsewhere throughout the code to make sure that when people come back and look at this in the future, and there's a line of code that doesn't make sense when you first look at it, that there's a comment there that tells you and kind of guides you as to why that's there and what makes that important, and why we can't just strip that out. It has some kind of significance for how that function works in Metpai. And so writing that documentation firsthand for these new features was really valuable experience. And then beyond that, figuring out how to appease the GitHub actions was another interesting process. GitHub has set up, or we've set up on the Metpai GitHub, when you submit a pull request with your new code, Flake 8 linters, so that your code is written in the same style, a consistent style as the rest of Metpai and Python as well. And then making sure you have unit tests that cover your entire code, and making sure your unit tests pass. And specifically for our declarative interface, image tests are a big part of this. And so when we're making maps and we want to make sure that that we're testing that these maps work, we have to have a baseline image, and then when the test runs, a new image is created, and we make sure that those two images line up. And if they don't, we know that something's gone wrong and we need to take a look at that. And so just the entire software development process with Metpai has been a really great learning experience overall. So I kind of highlighted 4 things here that I worked on this summer that are related to our declarative interface. And so these provide users with greater control over how they design their maps. And we also introduced some support for new data formats that users can take advantage of. So the first one we have here, easily zooming in and out of maps. When a user's creating a map with the map panel class, we have an area attribute. And so typically someone can put in just a string, or rather a list of 4 latitudes and longitudes that they want to use to bound their map north, south, east, and west. However, Genpack had the ability to type in a string as well, and these strings correspond to latitudes and longitudes bounding the map. So for example, the one on here is CO, which stands for Colorado. And so you get a map that is centered on the state of Colorado when you type in CO for the area of your map panel. So another thing that Genpack had was the ability to add a plus or a minus after that string in order to zoom in or out of the map. And that's something that we didn't have here in Metpai before version 1.1. So one of the things I worked on this summer was adding the ability to take that plus or minus and figure out, okay, how do we zoom in and zoom out of the map appropriately with that plus or minus sign. And so this was actually really interesting because at one point we dug up some of the Fortran code. This was Ryan, Kevin Gobert from Valparaiso University, and myself kind of looked into how did we do this in Genpack, and how do we make sure this looks similar to what Genpack was doing. And eventually we dug through and found where that was in the old Fortran code, and we were able to figure it out so that the plus and the minus in Metpai acts very similar to the way it did in Genpack. And so that was really interesting to work on. Another thing, plotting common formats of GIS vector data. So there's a lot of data out there from sources like the Storm Prediction Center, the National Hurricane Center, as well as a number of other sources that provide their map-based forecasts or map-based products in either a GeoJSON or a shapefile format, which are traditionally these GIS formats. They're meant to be plotted in things like ArcGIS or QGIS or traditional mapping software. But a lot of those things are actually really useful for just maps in general. And we wanted to be able to include those in maps that we're creating in Metpai. So while this isn't something that's from the Genpack software package, it's something that we think would be really useful for users, especially because there's meteorological applications to these file formats. And so the image you see there is the Storm Prediction Center Day 1 convective outlook. And, this is the first thing you see on the Storm Prediction Center's website. But now this is something that users can download from the Storm Prediction Center and actually include in the maps that they're making, and potentially overlay that with other layers like contours, wind barbs, and supplement their weather analysis with data from these file formats. And so this was probably the most interesting thing I worked on this summer, because I actually got to see some really interesting results with this. And I put together a Jupyter notebook that I will go through just at the end of this to kind of display all the different things, or at least a couple of the different things that we can now do with this new plot geometry class in the declarative interface for these techniques. So the next thing I worked on was adjusting font size for text in our maps. And so before Metpai 1.1, we actually had very limited ability to change the font size for different elements of our maps. And so now we're able to take the titles of maps, contour labels, color bar labels, and text from station plots, and customize those fonts so that potentially they're easier to read by making the fonts bigger, or making those fonts smaller, and kind of minimizing those features. So this provides the users, our users, with quite a bit more flexibility in how their map looks when they want to go and present this somewhere or use it in a paper. And they now have the ability to control the font sizes for those features. And then the last thing here, duplicating plot objects. This was the first thing I worked on in the first week or two of the internship. And this was brought up by Kevin Gobert from Valparaiso, and he wanted an easy way, I believe it was, he wanted an easy way to be able to duplicate some of these objects from the declarative interface. So if we have a barb plot here, you can see on the left side these barbs are blue, and then on the right side we have green barbs. And rather than creating the entire barb plot over again just to have green barbs, we wanted to make it easy for users to duplicate what they had before, so basically a copy and paste feature, and then make those blue barbs into green barbs with just a couple of lines of code, rather than having to recreate the entire map. And so that was another feature that allows users to easily manipulate how their map looks, and just general ease of use. And so I also have a Jupyter notebook here on the bottom left, and that one goes through how all the examples on this poster were made. So the zooming in and out, the Storm Prediction Center map, and all the other plots on here, that QR code leads you to a notebook that explains all of that. But for right now, I'd like to go through a different notebook that I put together when I was creating the plot geometry class for the ability to visualize data from GeoJSON and shapefile formats. And so this started out as just a proof of concept notebook. Like, is this something we can actually do? Is this going to be something that's simple enough that we can already do in matplotlib, and then kind of package it into a new class for Metpai so that it's easier for users to implement and put together these maps with GeoJSON and shapefiles. So this is a list of all of the attributes for this class. The first one is geometry, which is just a collection of the shapely objects that are going to be plotted. And so I'll explain that in just a minute, what shapely is and how that works. But this is basically the list of things you're going to plot. And then the rest of these are basically optional. Users can decide how they want the fill, outline labels to look for their maps. And so the first one here is the Storm Prediction Center map. And the power in this is that all you have to do is create this plot geometry class and then provide it with the list of things you want to plot and provide those the things you want to customize it with. And then the declarative interface takes care of the rest. And so when we are reading these GeoJSON and shape files, we actually have GeoPandas take care of that. And that's probably going to be the most common use case for our users, is that they're going to use GeoPandas to open up these files and turn them into a geodata frame, which is just a pandas data frame, except we have this geometry column over here on the right side, so that has all of the location data, all the geometry data about what needs to be plotted. And so providing these to the plot geometry class, we just have a list of the shapes. We have the outline color, we have the fill, which are already provided in this geodata frame, because this was parsed or read from the Storm Prediction Center's file. They conveniently already provide those colors in their file. And then we want to include this column as the label column, and we increase the font size for the labels so they're a little easier to read. And with those few lines, you can create this map that can supplement meteorological analyses, and just there's a lot of customization for users. And so another example is from the National Hurricane Center. They provide these wind radii forecasts for their upcoming storms. And so we don't have any storms in the Atlantic or Pacific right now, but they provide an example on their website of what their shape files look like. And so all of their examples are from Hurricane Irma. And so we can read this shape file, and this is what it looks like when GeoPandas takes a stab at it and reads it. And then we kind of combine together all of the shapes by their wind radii, and then giving that fill, stroke, and labels, automatically we can create this plot that has the wind radii already there. So basically taking these products from the National Hurricane Center and Storm Prediction Center and making it really easy to integrate these into Metpai. And so I'll go ahead and scroll down to the last one, which goes through some actually really interesting, this isn't meteorological per se, but it could be really great for weather maps in general, is the ability to include cities and roads in weather maps. And so here we've found from the census, these are all of the roads in the United States. And then we narrowed it down to just the interstates. And so GeoPandas creates this geodata frame with all of the interstates. And then we also found a shape file with all of the cities in the United States. And we narrowed that down to all the cities with more than 100,000 as their population. And once we go ahead and plot those, we do that here. We plot the interstates with dark green, and then we plot the cities as points with black fill and white outline. And then we get a map like this where, while this isn't meteorological per se, it can be combined with other layers and kind of augment the story that your map is telling in the Metpai library. And so the ability to include these GeoJSON and shape files in Metpai was, in my opinion, the most interesting thing I worked on this summer. And while I've only showed a couple of applications here, I think there's endless possibilities for what people can do in combining their analyses with the declarative interface, with maps from Metpai, and all sorts of sources for GeoJSON and shapefile data. And so to kind of wrap this up, a huge thank you to Ryan and Drew for all of their help this summer, and also everyone else who's here at Unidata. It's been quite the experience virtually, but I got a lot of experience out of it, and I really enjoyed it. So thank you.
Great poster and great work on the summer. Connor, do we have any questions for Connor?
I've got one. You mentioned toward the beginning of your, by the way, nice presentation, thank you.
Thank you.
But you mentioned toward the beginning of your presentation doing some work with image validation in the testing, and I know that that's a hard thing to do. And so I'm interested if you could tell us just a little bit more about how that's working now with the Metpai test suite, because like I said, I know it's hard, and I'd like to hear what's going on.
Yeah, so I'd say image testing was one of the most difficult things that I worked on this summer. Just in general, a very cryptic process. And so I think one of the hardest things was when we were working with font sizes in particular. There are older versions of matplotlib that just plot fonts in different ways, and I'm not exactly sure how all of that works. And it was interesting to learn where the line is between, okay, we're going to dig in and figure out how this works and make sure it gets done, or, you know, we spent enough time on this, we just need to up the tolerance on the test and let it go from there. And so, and there's smart ways to up the tolerance so that you're careful, you know, you up the tolerance just enough so that the test passes, and so that hopefully in the future we're still catching, you know, any maps that go astray. And so just, yeah, in general, kind of a tricky process, not something I'd experienced before.
Mm-hmm.
And yeah, so, you know, but it's an important part of keeping a library going and making sure it's up to snuff, everything's working well. So yeah.
Well, great, thank you. Thanks for doing that too, because I know it needs doing.
Of course.
Any other questions, Connor?
I do have one, actually a question and a comment. Can you please share with us the secret of doing so much in such a short period of time?
Well, it's a lot easier when you're an intern, I have to say, and you have literally no other task other than the one thing that you're working on. Outside of that, I really don't have anything else. I don't have any other tips.
Good. Great job, though, Connor. I do have a comment on the last part that you presented, which is the mapping of interstates and then the populations of plotting the cities. And you mentioned something very interesting, which is we can use this layer on top of or juxtaposed, I mean, superposed with more weather-related maps. And this opens up actually a way for more relevant, interesting discoveries doing just that. You know, like first thing that comes to mind is growing what kind of culture, I mean, agriculture in that area based on the weather that is there over time, and so on. So this opens up a huge possibilities for discovery of how we can manage things. You know. Yeah,
I really. Yes, thank you. I really enjoyed working on that feature for that in particular, the ability to kind of incorporate geography into the use of Metpai and maps was really interesting, and I think it'll be really useful as well.
Yep. Thank you.
Thanks.
All right. Well, if there's nothing else, then one more round for Connor here. And
Yes, thank you so much.